Welcome to Mission Innovation, powered by AWS. I'm Alex Martinez. I lead our global partner solution architecture teams for public sector, and I'm joined today by Christopher Finlay, Vice President at SAIC. Chris, can you give us a brief overview of your role leading engineering for SAIC's Innovation Factory?
Sure. Thanks, Alex. I'm Chris Finlay. I lead our engineering portfolio within SAIC's Innovation Factory. And within engineering there, my team is responsible for developing our innovative engineering products and solutions, the capabilities to deploy them, the workflows, the processes, the frameworks, the training, and then to provide the resources to go and execute on programs.
Fantastic. Modeling and simulation, design, it's all been critical across the federal government, but it's kind of traditionally been a little bit slow, resource intensive. And that's why I'm so excited to get a chance to talk to you today about how we're applying innovation to it. And that's really all about digital engineering. We're talking to customers now who are really changing their calculus about how they fall and go through rapid iterations, what they integrate across different types of engineering processes. And they're really using this idea of digital twins across all of the federal government while still driving efficiency into how they deliver those services. With that, as the Vice President of Engineering at SAIC, you're focused on this particular area. Why digital engineering? What led you to this path? Well, why did SAIC decide to invest in digital engineering as one of its kind of core strategic areas?
Yeah, that's the real question, isn't it? The answer goes back quite a ways. You got to go back probably 15 years or so before I joined SAIC, back to my time at ReadyOne, where we were working a program. I actually was able to use some of the earliest versions of some of the more popular digital engineering tools today. I like to say I was using them in anger. I had my, fingers on keyboards, meeting program deadlines to do a bunch of work. And I was able to see just during that first effort, firsthand, the value that doing digital engineering, it wasn't called that at the time, that it brought to the program. It was able to shift those defect detection curves to the left. It was able to provide clear, unambiguous models. And when change happened, we were able to do rapid impact analysis because we had, even back then, some form of the data was integrated and connected with upstream and downstream portions of the solution. Then over time, the DoD started to take a look at digital engineering. They stood up their digital engineering working group, which myself and some of my colleagues at SAIC participated in. And in 2018, they announced their digital engineering strategy for the world to get behind and rally behind, which we did. And that's when we started to make some investments in digital engineering. And then a little over a year ago, in late 2023, the Department of Defense released Instruction 5000.97, which at its real high level mandates digital engineering for all future engineering acquisition. And that was a celebration day for us. And it validated not just SAIC's investment in digital engineering at that time, but a lot of my own career and personal life decisions that I made to get us to that point. And that's kind of how my digital engineering journey went.
Well, that's fantastic. And we have a saying, there's no compression algorithm for experience. And it's absolutely the case here. And it's great to see the team led by such a practitioner that's been hands on the keyboard in understanding these challenges. Fast forward to today. What do you see are the biggest challenges that U.S. federal agencies have in their digital engineering initiatives?
I would say, from my observations and experience, a lot of our government mission partners are still trying to figure out how to do it, especially in light of the mandate. So now they have to go do it. So how do I do it? And there's a lot that want to do it. They understand the benefit, but again, they don't know how or where to start. So I think that's one of the biggest challenges. And some that have started, and some that are still looking to start, they have, and this is not just for digital engineering, this is any kind of new change. It's the culture and the upskilling aspect of doing something new or different. I like to say organizations are not going to be able to hire their way out of this problem. Digital engineering is still a niche skill set. There's not enough people to go out and bring them in to get you up and running. You're going to have to change your culture, upskill your workforce to be able to accelerate the pace of change.
Yeah, as technologists, we get really excited about what are the technology challenges, but it often does come down to the people, the process that really allows it to be successful. As I think about those people, outside of some of the federal spaces, we've had these huge disruptions and kind of compelling events, from supply chain disruptions that occurred during the COVID pandemic to increases in complexity of systems. We've gone to additive engineering. We have all of these new types of capabilities that are in the hands. How are you seeing those specific challenges impacting federal agencies and your end customers?
Right at its core, it's making it harder for our government partners to keep up with the rising costs. Even without the supply chain disruptions, the systems are just becoming more and more complex. Then you throw in the supply chains, and you throw in everybody else is also trying to keep up with technology. So we're trying to provide the outcomes that our customers need at the speed of relevance, is the phrase we like to use. So when you combine the need for it to be faster, the need for it to be cheaper, or at least not more expensive than it used to be, and it needs to be better, right? So, the old adage was faster, better, cheaper, pick two, right? They now need all three, and that's the challenge. And digital engineering is one lever they can pull to help get to some of those outcomes.
Well, we jumped in, and I know you've had a career of experience here. Maybe for folks that are, a little bit new to the technology space, when we hear digital engineering, what exactly is that, and how is it helping kind of get, as you mentioned, all three areas of the price performance technology triangle?
Yeah, digital engineering is engineering gone digital, and what that means, from my perspective, is taking the way we traditionally did engineering solution development using what I'll call document-based methods, Excel spreadsheets, PowerPoints, Word documents, 2D drawings. I know we're long gone from where we used to hand draw the drawings, but doing some kind of partial modeling and then putting everything out on a flat file. It's taking all of that and getting all of the solutions into digital models and any relevant data into databases. So that's digital engineering at its core. But in order to really unlock the value of digital engineering, it's to connect that data together. So how do I connect the requirements to the architecture, to the CAD, to the electrical, to the software, to the mission data that we're collecting for sustainment, and tying that all back in? So that's connecting all of that data. We call that the digital thread. So being able to not just connect the data within a particular engineering domain, but across those domains as well. So that when you do that, you have better you have a better idea that your design, especially as they're becoming more and more complex, that your designs are complete, that they're consistent, and you can trace. And the traceability is important because any system that we've ever developed changes over time. And when you make that change, you want to be able to do rapid impact analysis. I like to say you want to know what you're stepping into before you step into it. And having that digital thread with all that connected data allows you to do that. Fast forwarding to AI, if you don't have your data digitized, you can't start to take the steps to get to AI or generative AI. So it's almost like the foundation for being able to get to generative design.
Yeah, I mean, that's a fantastic description, and you're really already kind of telling us something that we should expect to see. And so I'm curious, given where we're at today in this, data-focused effort, where do you see digital engineering going over the course of the next few years? And, how do you see that incorporate this digital thread that you described and really bring on some of these new disruptive capabilities, as we like to say at AWS, to really continue to reinvent digital engineering?
I'll group it into three areas to kind of get our heads around it. The first one, I'm going to say real-time digital twins. And we're starting to see that from our customers and experience that digital twins are getting a lot of return on investment. So what is a digital twin? A digital twin is a virtual representation of a physical asset that's in the field. So if I have a tank that's fielded, right, I've got a digital twin. I've got some portion of that tank is modeled in some kind of computational model or some real-time status dashboard, and it's mapped to serial numbers, right? So having real-time digital twins, being able to monitor, in the case of the DoD, what's going on as we're fighting a war, so we make decisions for any kind of situation where we've got assets deployed, being able to use that information and then to combine it with AI to do performance-based logistics, right? Or look at the data and say, hey, maybe it's cheaper to spare this a little bit more often than to go and actually redesign the part, requalify it, and then install it. And then it gets into the second thing, which is AI for DE, artificial intelligence for digital engineering. As we start to add more and more sources of truth to the digital thread, we can leverage AI to turn that 1x engineer into a 10x or a 5x engineer, right? Meaning, today I can only do so much, right? But tomorrow, with digitized data and maybe agentic AI, I can start seeding models faster or making better decisions or reviewing my work. So before I get it out to review, further shifting my defect detection curve to the left. And then the third one is a little bit of a play on words, but I call it digital engineering for AI. So I flipped it, right? How do I get AI to the edge where the end users are? It just doesn't show up, right? I know the cloud, right? But the reality is, if I'm going to the moon and I want to leverage AI, I somehow need to get that software, those algorithms, to the moon, to Mars, to the battlefield, to the bottom of the ocean, wherever we're doing the work. And the data has to come from somewhere too. So long before you get there, you have to engineer a system, and I like to call it system engineering mastery. And I think digital engineering can provide that system engineering mastery to allow us to bring AI to the edge, right? Kind of bring that complex system together.
Yeah, that's fantastic. And I love the play on words, right? Where you're using the technology that's adopted AI to really then go build what that new framework needs to look like to get these technologies really into the hands of the end users in all the different austere environments that they face challenges. This is an area clearly you didn't wake up, yesterday and say, hey, we want to be in the digital engineering area. SEIC's been doing a lot of investment over time, but you did mention the DoD instruction, right? So just recently came out. You alluded to this earlier, but I maybe wanted to get to a more concrete example. We hear from customers often that they want to get both these new capabilities, but they really want to drive also the efficiency and perhaps not at the existing budget, but they're actually looking to say, how can I be even more efficient in my delivery of these capabilities? And so can you give us an example of how digital engineering is being used to drive efficiency and what kind of outcomes customers are getting from these changes of how they be able to go develop and create these new systems?
Sure. Can't mention the customer's name.
Of course.
Right? Didn't get prior approval. But a great example, I think, really illustrates the efficiency and the power of digital engineering. We had a customer that was maintaining a many decades old facility that was doing testing for critical equipment for one of the branches of defense, and it needed to be updated just to handle more throughput, to keep up with the technology of the systems that were coming through that facility. And they had purchased a whole set of equipment to upgrade. But over the years, right, that facility expanded and grew, and it was a patchwork of things, and they didn't really have any good documentation of how anything worked. So they spent a lot of money buying the equipment, and they were nervous that if they started to replace this critical equipment, they could, if it didn't come back online correctly, they would go from just having not enough throughput to no throughput for a period of time. And so they brought our team in to go and model those systems. And we modeled using digital engineering techniques, we modeled the as is, and then the to be with the new equipment. We created a digital thread between the system architecture models and the performance simulations to show that they were going to get the performance. It gave them the confidence to then go forward and actually change that out and increase the throughput of their facility.
Oh, that's a fantastic example. And it sounds like you've got this capability increase as well as you get confidence that you could actually execute and deliver it. Maybe what are some of the other dimensions of capability enhancement?
One of our products is called ReadyOne, and that is an integrated digital engineering ecosystem where we take some of the best digital engineering and engineering tools out there from any vendor. We connect all of those sources of truth together into a digital thread so they can have a digital thread right out of the box, and they can start making inferences on their data, making sure, like I said earlier, their solutions are consistent, complete, and traceable. And it's available to all of the players 24/7. So that's another thing. As the systems become more and more complex, no one organization is doing all of the work anymore.
That's right.
So how do we break down the organization of silos through these digital engineering collaborative ecosystems? And I should mention that we use AWS GovCloud as one of the key tenets of our ecosystem that allows folks to access it from anywhere.
That's fantastic. I mean, that's really what we talk about when we talk about mission innovation and what we want to get in place. And appreciate the perspective about how we've been working together with AWS to help support your teams. SEIC and AWS have put together a very strong partnership. Maybe could you explain, how does that partnership and the collaboration with AWS teams help you deliver those digital engineering capabilities?
Yeah, we have a great relationship working with you guys at AWS, and it's been going on for probably a good 4 years now or so. We probably talk a couple times a week with your teams, not just to say hi, but to actually continually solve hard problems. I had mentioned ReadyOne earlier. That's our rapidly deployable digital engineering ecosystem. And we were just at a point in SAIC's evolution where we had to upgrade our servers and our infrastructure where our digital engineering tools resided. And we said, hey, let's go join the new century. And instead of going buying more equipment that may or may not meet the demand over a certain period of time, we decided to move to the cloud. We decided to go to AWS GovCloud. And like I said, we've been working with your team for several years now. And it's a home for where SAIC does their engineering work, and then we also can bring it to our customers' GovCloud space as well, so they can have that collaborative session. And then we've gone so far to do executive visioning sessions with you all. We went out to your headquarters out in Seattle, which was a really enlightening experience where we started to unlock where we could go jointly to take our digital engineering and our ReadyOne ecosystem to the next level. So,
sometimes folks, the hardest part is getting started. What advice would you give to an agency? They've heard you kind of talk through the outcomes, the benefits, where the future is going, but they're not there yet, and they're ready to get started. What's the first step?
I think that selfishly, the first step would say, give us a call, right? Just at that higher level, look for those proof points in the industry, because there are some out there now. It's not like five years ago where everybody was talking about doing digital engineering, right? And with a few companies that were actually doing it. Now there's a lot more companies that have proof points. So seek out those bona fide proof points, or look for customer testimonies. There's no shortage of information of people that have either rightly or wrongly claimed benefits of digital engineering for their organization, right? And like I say, find folks that have experience using digital engineering in anger. And whether you're reaching out to us or someone else, put from our drive. Don't recreate the wheel. I mean, one of the reasons that we're doing what we're doing is to help elevate the entire industry for the benefit of our customers. So don't recreate the wheel where it doesn't need to be recreated, but from the drive.
Yeah, that's fantastic advice. Don't suffer in silence to try to learn this. It's been a real pleasure getting an opportunity to hear from someone who's grown up in the field, and is now leading and being able to create the future of it in digital engineering. This is exactly the type of capability that we get excited about here with our mission innovation powered by AWS, because we're seeing the technology be applied to really change outcomes, as you said, in all the environments that the end users are looking for. And particularly with the focus that the Department of Defense has, we've got a great set of capabilities we've worked together with, and we have a great part for folks to get started. So they don't have to go at the beginning, but they can learn from all that experience that the team's brought together. So really excited. We'll be able to share with folks how we can get in touch with SAIC, learn about ReadyOne, and take that information to begin their journey in digital engineering. Thanks again, Chris.
Thank you. Appreciate it.